Thanks. Hi, everybody. So that was very clever to just restrict the Americans to just an hour and a half, all at one time. Super good strategy. I've given a lot of talks in Norway, but I've never given a talk to a group this large in security, and that's impressive. So what you guys have done to build this thing up, wow, it's super good to see. So Lance just talked a lot about monkeys or humans. And he said that the problem with security is monkeys. And I pretty much agree with that. But I want to talk today about the most dangerous monkey of all. And that is a monkey with a compiler. So let me give you a little bit of background about me. That's me playing the violin. That's me with a lightsaber at RSA. And that's my big solstice bonfire. I'm actually a retired guy. So I retired in January, and all I have to say to you is do not retire. It's a bad, bad idea. For 25 years before that, I worked on software security, and I got started in software security when this language called Java came out. Anybody ever heard of Java in here? And there were claims made like, everything you build in Java will be secure. And, yeah, it didn't work, did it? So there were some people breaking Java in the mid-90s, and that was me with Ed Felton. And it made me wonder why the people who built Java itself screwed it up. And where would you go to try, if you were trying to build something to be secure, how would you do it? And really, for the last 25 years, that's what I've been working on. So software security is near and dear to my heart. But lately, since I'm retired, I've been working on machine learning. And I have an institute called the Berryville Institute of Machine Learning. There's our little logo right there. The idea is exactly the same as software security. When you build a machine learning system, when you're putting one into a bigger system of your own, how do you build it to be secure? And all of the same questions that we've been trying to answer in software security for the last 25 years that I'm going to tell you about this morning apply directly to machine learning stuff. So I'm not talking about that today. Maybe next year we'll do a talk about machine learning stuff. So that's what my background is about. Now I want to convince you that the biggest problem in security is not actually the monkeys, that's actually the software that the monkeys write. Right? So, software is everywhere. It's really hard to avoid coming across software every day in the modern world. In fact, software is working its way into things like the electric grid in our cars and telecoms and our banking system. There's just so much software, it's not a surprise that stuff barely works. Because as a software guy, I know that when you get it to compile, you can just ship it, right? And so, when you come to the security people and the software people and you try to mix them together, that's where we get some issues. Of course, the problem with the monkeys that have compilers is that though they might want to do security right, nobody ever told them how. And so, as Lance said, if you would like people to change their behavior, one of the things you can do is educate them about how they should do some stuff and why they should do some stuff and what stuff they should do, all the things that you mentioned. And that's important, but I think the key thing is trying to build software that doesn't suck. One of the overused analogies or metaphors in security is this perimeter security idea. Now, I know this is going to be tough, so we're going to go through a thought experiment. Imagine that you're a Viking. Oh, come on. Imagine that you're a Viking and it's 1350, and you come up to borrow some people's stuff in, say, I don't know, Wales, and you and you get to this place and the edge of technology is metal, and you're carrying heavy stuff, and then you see this thing surrounded by water. Now, that's not really a problem for Vikings, but putting a moat around a castle was a good idea in 1350 or whatever. But if you wanted to attack a castle today, what would you do? Well, just have a predator drone fly over there and bomb it from the middle. So one of the challenges we have in security is the idea of protecting the broken stuff from the bad people by putting a thing around it. The real question to ask is, why is the stuff broken anyway? And how can I build stuff that's more secure in the first place so that I don't have to always protect the broken stuff from the bad people, but instead I have stuff that's not broken? Now, I heard that there was a requirement to have a Bruce Schneier quote in your slides. So here's the actual quote that you were talking about in Applied Cryptography, where Bruce said, I wrote Applied Cryptography and I thought crypto could do everything and that was wrong. But it's not really just crypto that's the problem when it comes to security, in particular software security. People who build systems for a living, developers that is, think about features and functions all day. And their first thought when you say, well, we need some security in that system is, well, surely I should just add a thing into the system. Security must be a feature or a function of some sort. Maybe it's magic crypto fairy dust. Maybe it's something else. Maybe it's like perfect authentication or something like that. But security is not a thing. Security is a property, as we all know. Now, the good news from Geekland is, in engineering, we are familiar with emergent phenomenon and emergent things like security. If you think about safety, even if you think about reliability or functionality, those are not things that you add to a system. Those are properties of a system itself. And security is very similarly a property of the system itself. So one of the things we have to teach developers is you cannot just add something to your software. Instead, we just need to think about security while we're building it the whole time and try to build it with fewer defects. Now, there is no such thing as perfection in security. Lance said this, and he's exactly right. People who try to make a perfect system will fail every time. And in fact, you can spend way too much money trying to secure a system that doesn't really need to be secured. The question that you have to ask yourself in security is, how much security is enough? How much do I want to spend securing this system or teaching the people how to secure this system? And how do I balance that out against who might possibly attack this thing? Because, security may be a little bit about economics, it may be a little bit about human behavior and psychology and Kahneman's work and stuff like that. But it's always about finding the right balance while you're building a system. So risk management is something that's also on the agenda in a lot of places during this conference, and that's good. I think that's the right way to think about security. So those are the basics of software hits security. Now I want to talk about software security itself. The biggest problem that we have had for 20 years in software security is who should do it. So if you think about it, if you go over to the network people in the old days and you said, all right, you guys, you're doing security well, we have the firewalls and we have our network locked down, we don't have open services, we're updating stuff properly, we're authenticating our users, all that's good, except for what about that software that we're building? And the network people would go, oh no, we don't know. Software's over there. Just go talk to the software people. By the way, those monkeys with the compilers, those are the worst ones. Like, we don't like the users, but we really don't like the developer users. And so you sort of, as a software security person, back away from security and go, okay, all right, maybe we'll just go talk to the developers. And if you think that security people see themselves that way, you ought to see what developers think of themselves. They're much more like the Matrix guys, right? So you go over to software and you go, all right, you guys, the security people said that you're responsible for securing your own stuff. And they go, security? Isn't that about like antivirus and, firewalls and stuff. I had this great program once, and I tried to install it, and it didn't work because of the firewall rules, and I can't even get anything to compile because of all the security crap they have on my box. The build machine is all bogged down with security crap. I hate the security people. Oh, no. So we got these people saying that they should do software security, and we got these people saying that they should do software security, and who's in the middle? It's on the slide in red. Who's in the middle? Nobody! Yes, nobody's in the middle. Now, here's some Management 101 stuff. If nobody's in charge of software security, who gets fired when software security goes bad? Nobody! Yes. Well, who gets a bonus when software security goes right? No, the CEO always gets a bonus. Jeez, come on. So one of the things we have to figure out in software security is who should do it. And there's a group of people called the Software Security Group that a lot of organizations have formed that actually doesn't always report to security. It's usually in engineering. And this is not just security people running tools against software, but it's actually a group that helps development build stuff better, both from a design perspective and from an engineering perspective. My belief is that you have to have a software security group if you have a significant software development presence in your organization and you want to get software security done. Really, in my experience, that's the only way to do it. And Lance, when you showed the slide about Microsoft and all the great stuff that they did in the Trustworthy Computing Initiative, that was done by Microsoft's Software Security Group over 20 years. And it was important work that they did, albeit very technical. But if you want that work to get done, the nobody answer has to change to the Software Security Group. Now, let's see. In 2006, I wrote my fourth book on software security, and I titled it something obvious. I think it was called Software Security. And in that book, we put forth these things called the Touchpoints, and there's 7 plus or minus 2 of those. The reason we have 7 plus or minus 2 is because psychology, right? But there are only 3 that are super important. And this is the order that you need to apply these kinds of practices in when it comes to building secure software. Number 1, all software projects have code. So you can do a code review with a tool looking for bugs. And sadly, since the compilers don't look for the bugs, we have to have a thing that's kind of like a compiler look for the bugs after the compiler didn't look for the bugs, and we call that a static analysis tool. This is getting much trickier with dynamic languages like JavaScript and Node.js and all these assemblies that get assembled on the fly. But looking through your code for bugs is the number 1 thing to do in software security. However, there are 2 kinds of defects in the world: bugs in the code and flaws in the design. And you have to look for design issues as well when you're creating a system. That's what practice number 2, architectural risk analysis, is about. So those are the top 2 things to do in software security. The third thing is pen testing. Now, when you go to most organizations and you say, what are you doing for software security? If they're doing anything at all, guess which thing they're doing? Number 3. Don't do number 3 first. Do number 3 third. Here's how pen testing works. We hire some reformed hackers, and we know they're reformed because they told us they're reformed. And we decide we're going to give them a week. That used to be expensive, like $25K for a week of pen testing. Now it's more like $7,000. So $25,000 to $7,000. I don't know how many kroners that is. A whole lot. I think you multiply it by 10, basically. So, what's happened is penetration testing has become a commodity over time. And if you're a penetration tester for a living, the service that you're providing is worth less now than it used to be. And it's going to get worth less and less, by the way, just so you know. So we hire these reformed hackers. We pay them $7,000 for a week to find some problems. They find 5 problems. They tell us about 3 of them. We look at the 3 and we go, wow, that one's hard. Maybe we'll just put that aside. And then you go to the second one. Oh, I can kind of sort of halfway fix that one, so you halfway fix that one. And then the third one you go, oh, that's easy. I'll totally fix that one. So you fix that one and introduce 5 new bugs. Now how many bugs are in the system? More than you started with. Because economically speaking, it's very silly to build a broken thing and then try to fix it into a not broken thing later. So penetration testing deserves to be number 3. That doesn't mean we should not do it. We absolutely should. And there's some fantastic pen testers, people that attack systems in interesting and novel ways that we need to use their brains to do this. But really, there's some basic blocking and tackling in development that we need to do first, and that is code review and architectural risk analysis. The second thing I want to tell you about that's super obvious from software security is there is no such thing as a magic box for telling you whether software is secure. There are a lot of vendors who would tell you, if you just take the software and you put it in our magic box, it'll turn green if everything is secure. Those people are either really bad computer scientists, or they're hucksters, or maybe both. Because anybody who knows anything about computer science knows that we can't even put a program in a box and have the box tell you whether the program stops. We'll call that the halting problem, which is a theory thing. I mean, you don't get to not have the halting problem. We just have that. So we can't sort of avoid that insecurity. It's super important to think about what a testing regime is really about. So imagine here's how we do testing. We have a really super smart elite hacker like Moxie Marlinspike, and we take Moxie's brain and we put it into a can. We get a can of tests that will work on any software, so they're pretty darn generic, but they're in a can, and then we run that can of tests against some arbitrary piece of software. Now, we have program A. We take the can of tests, we run it against program A, and we find some problems. What do we know about program A? Anybody? We used the can of tests, we found problems in program A. The can didn't even know about program A before we ran it against it. What do we know about program A? Is it good or bad? Come on. It's bad. Like if an arbitrary black box test can hack your code without knowing anything about it, your code is bad. In fact, there's a technical term for how bad it is. That is, it sucks. And we're at the state of the world now where, we run can tests against programs that the can tests don't know anything about, and the can tests break the program all the time. That's scary. Okay, here's scenario 2. Same can of tests, program B. We run the can of tests against program B, and we don't find any problems. What do we know about program B? It probably sucks minus 10 tests, right? So that's the thing. There's no such thing as a security meter, right? We run the can tests find problems, deep trouble. Or the can tests don't find problems, we get all the way to who knows? That is a badnessometer, not a security meter. It's super important for all of you people out there doing security for a living to know that a badnessometer is a fine thing to use, but just don't treat it as a security meter. And you know what? Senior management, they're going to want to treat it as a security meter if they even hear about it. So don't tell them about it. Sorry, that's the anti-communications message, right? All right, number 3 thing in software security, super important. We've learned kind of what we need to do. We've learned who needs to do it. We've learned, some stuff about badnessometers. And now we're at the most important thing in software security, which is if you find a bug, it's not fixed until you fix it. So if you spend a lot of time finding bugs and you just pile them up over there, you're probably in worse security position than you were before you started. It'd be better not even to look for the bugs if you're not going to fix them, because then the lawyers will get involved and they'll be like, you knew that the Pinto was going to blow up when you drove into the back of it and you sold it anyway? Yeah, that's kind of what we do in software land. You knew there were bugs and you sold it anyway? Yeah, I guess we did. Sorry. So the real question is, well, which bugs should I fix? There's a lot of bugs, and which ones do I pick to fix? How long does that take? How can I tighten up the loop between finding and fixing bugs? And the answer is a combination of things. One thing that's super important is get to the keyboard. If you got a problem between the keyboard and the computer and the person in the keyboard and the computer, you want to tighten that loop as much as possible. When somebody's typing in a bug, you should go, hey, we taught you not to do that last week. Remember that thing that you slept through? That secure code training thing? Yeah, well, don't do that. Do it this way instead. And, automatic systems that can do that sort of thing quickly so that you can fix your code immediately when you're typing in are way more important than ones that happen at build time. We need some at build time too, because we can't always find them using syntax alone at the earliest typing stage. We need to have a build. This becomes a problem when we have DevOps because you have an assembly and the assembly gets assembled when? Right before it runs. So there's some URLs and we hit them and we drag some code down and we splitch it all together and then we run it. Oh, if you're a security person, you should go, ow, 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 ow. That's what? We do what? We get some code from where and we put it together and then what? We run it? Guys, that's how the web works now. Your developers are building stuff like that. And so the question is, well, does that URL return the same glob that it returned last time when we checked it during the security review? Who the hell knows? You just got to go see what it is. Which means, we have to check the security in real time in DevOpsy land and web, who knows, assembly, JavaScript land, because here's a secret. If the code is not around yet, you can't check it. I know it's tough, but you have to get the code, then you can look at the code. And the problem with the modern paradigm of software development is you get the code only at the last minute right before you run it. So you got to get the code last minute right before you run it, check it, and then run it, maybe. Right? So and we want to speed that up. We'll call it DevOpsy, Ops Dev. All right. Now, here's just a pet peeve thing. This is not as important as the other stuff I've been teaching you about software security, but it is kind of important. I've already said this once. There are two kinds of software defects in the world. There are bugs in the code, like on line 42, you use the wrong system call in C, and that leads to a security problem. Buffer overflows come that way, SQL injection stuff comes that way. Those are bugs. There are literally tens of thousands of things that you can do wrong in lots of different tech stacks, and there are automated systems for finding bugs. Of course, if we find the bugs, what do we have to do? We have to fix them later. But that's really only half the problem. The other half of the problem is design-level issues. And design-level issues are much trickier to fix. In fact, in our consulting practice over the last 20 years, when we would find an architectural problem, we would often have to have a 5-year plan for getting that fixed at, say, Citibank, for example. So it takes a long time to refactor 25 million lines of stuff into something that's more secure at the design level. What this means is, if you think about security while you're designing something, you're going to be in a much better situation than if you wait till later. So great ways to think about security at the design level include Ross Anderson's book, Security Engineering, which is now in its 3rd edition. Ross is writing chapter 4, I think, right now. If you only read one book in security ever, it should be Ross Anderson's book, Security Engineering. Just fantastic work. One of the issues that we have in software security is if we try to simplify too much and we just say, well, it's all about the bugs, then we can simplify even more and say, well, it's only about 10 bugs, like the top 10 bugs. Then we can fix those 10 things and there'll be what? 9,990 left, plus all the flaws. That aside, it's probably better to have 10 things you're looking for than 0 things that you're looking for, right? So that's good. What do we look for when it comes to design problems? Let me give you an example of a design problem, just so you know what I'm talking about. You ready? Here it goes. It's really tricky. Forgot to authenticate user. That's the whole thing. Anybody can run the code. Doesn't matter who they are. They can just run it. That's the way developers are just like, well, I made the code for somebody to run, so I hope they run it. It's like, who's they? Oh, anybody. Oh, what does that do again? Yeah, so, that's an example of a design issue. And for years, there was not enough written down about design, even though we've been writing about things like threat modeling and architectural risk analysis for almost 10 years now. So we built this thing called the Center for Secure Design in the IEEE. I got together some friends of mine who were software architects from a bunch of places and said, you got to bring flaws. And we didn't have a discussion about what a flaw was. People just brought their pile, and we had to share them. We put them out on the floor. Everybody's cringing. Oh, my God, you did that? Wow. Everybody. Then we got bulldozers, and we moved the flaws around into big piles, and we found 10 sort of big piles of flaws. And then we said, well, we can't just talk about what the flaws are. We got to talk about how to avoid them. And we wrote it all down, and we put it out under the Creative Commons, first thing that the IEEE ever put out under the Creative Commons. And you can download it. So there's a URL for that. All of your software architects should be reading that. It's pretty easy read. And one of the things that we did with the results of that work is fairly generic. Twitter took that work and made it work for their own security framework, their own development framework, that is. They made changes to the framework that the devs use all the time to create stuff. Facebook, same thing. So, you can make a difference when you think about the architectural level. All right. Since we're on pet peeves, let's have another one. This is my current pet peeve. SecDevOps is not good for security. That doesn't matter. We're going to do it anyway. It's happening. DevOps is happening. We have to deal with it. The security paradigm that we had, time to review the code and architecture analysis and all that stuff, wow, I don't know how we're going to fit that into DevOps. So we have a challenge where we can automate looking for bugs, so we can put that into the loop, but we really can't automate yet looking for flaws. So we don't know really how to do that. Plus, the loop's getting tighter and tighter. And get this, all those containers and all that scripty stuff that you use to do the assemblies and all the Kubernetes stuff, all that stuff, guess what it is? Code. It's software. So we're making even more software. And here's the best part of all. The IT people who used to do ops? They're gone now. We just let dev do that. Yeah. So those people who used to be the bad people who said no, well, they're gone, so there's no anymore. Which is fast. And it's fast. All right, so have fun with that. I'm really glad I'm retired about that part. Now I want to tell you about a project I've been working on for a decade for the last 10 minutes or so, called the BSIMM. I'm actually a scientist. I do have one of those PhDs. Actually, I have a PhD in cognitive science and computer science. And I didn't study anything about security in school. I actually worked on machine learning stuff 25 years ago, which is why I'm doing it again. But, I still think like a scientist. And as Lance was suggesting, the thing you really need to do first when you're taking a scientific approach is get some data and look at it. Try to figure out what's really going on out there in the world. So my career has kind of been studded or embarrassed by a series of experiments where we just grabbed a bunch of data and let the data speak for themselves. The BSIMM is one of those. It turned into a measurement tool for software security, but really it's a science experiment that escaped the lab and a community of people. Here's the deal. There are 167 firms in the current version of the BSIMM. There's a new one coming out soon, I think. I'm not working on this project anymore, by the way. There are 389 measurements of software security initiatives. So remember when I said nobody's in the middle, what we need in the middle is a software security group doing some stuff like the Touchpoints, code review, architecture analysis, penetration testing, that sort of stuff. Those are the people that we were measuring in those 389 measurements. And a bunch of those have been measured twice. One of them has been measured 5 times. So we just basically go and we find out what firms are actually doing when it comes to software security. In the early days, Microsoft was part of the BSIMM. And you know, when I called them up and said, guys, we're going to do some science, to Steve Lipner, we're going to do some science. Would you tell us about what you're doing in software security? They said, absolutely. We really wonder what everybody else is doing. You know, one of the problems in security that's a human-level problem is the lack of communication between groups in different firms. That's the coolest thing about this conference with 1,200 people from Norway all doing security. You guys talk to each other, learn from each other, talk about what works, talk about what doesn't work. Because out of the BSIMM, the most powerful thing that we built was a way for people to talk to each other using the same terminology and the same measurements about what was going on in software security. So here's some of those firms. You'll probably notice some of them. My favorite ones are the ones who first got hacked, like Equifax and Target and, you know, who else? Home Depot, who, after they got hacked, they're like, gosh, maybe we should join the BSIMM now. So maybe the BSIMM's kind of like jail for people who did it wrong. But, you know, then there's security companies up there, like Symantec's up there and some others. You know, there's some banks, Bank of America, Wells Fargo, JP Morgan Chase, the biggest banks in the world. There's people who build chips. Qualcomm's in there. There's people who do IoT. There's people who do lots of embedded technology. I know we're working on car companies now. Suffice it to say, these are people who build real software that does real stuff every day, and the question is what they're doing. So the BSIMM just tells you what people do or what firms do. The question you should ask immediately is, well, what if they're doing the wrong thing? Well, they're all collectively insane. They could all be doing the wrong thing. The BSIMM is just going to tell you what they're doing, and you can decide whether that's good or bad. But it's better to know what people are actually doing than not know anything about anything. So, you know, the BSIMM is a descriptive model. It doesn't tell you what you should do. It doesn't tell you what you ought to do. It tells you what everybody else is doing. And it tells you how many of those everybody else is doing what for a whole bunch of practices and activities. That's real data about actual things that people are doing in security, and it's not real data about whether it works. We're just assuming that they're not all collectively on crack, but they could be. So to make this translate into monkey land, it goes like this. The BSIMM tells you that you go out into 47 jungles and you find that monkeys eat bananas in 38 of the 47 jungles. And you can say, 38 jungles worth of monkeys eat bananas. We're not sure about the others. There are 48 jungles we looked at. That's what the BSIMM does. The BSIMM does not say, do not run while eating bananas. That's prescriptive. The BSIMM does not say, thou shalt not steal thy neighbor's bananas. Because that's religion, not descriptive. So the BSIMM describes stuff. And once we describe stuff, we can come up with some cool numbers. This is my favorite chart of the BSIMM. It goes from 9 firms 10 years ago to 120 firms that has 415,000 developers developing 135,000 applications. And guess how many people are trying to secure the work of those 415,000 developers in the community? Well, it's SSG members plus satellite members, so that's 7,800 people doing software security full-time that are described in the BSIMM. This is not pretend, this is not theory, this is real stuff. The big problem is if you think 7,000 people trying to control the work of 415,000, that's not fair. It's not. It's kind of like security. Are you like woefully outnumbered by the not security in your firm? Probably, unless you're a security vendor. In which case, you really need software security, by the way. Yeah. Right, so there's some numbers about that. And you can see that, financial services firms, ISVs, tech, healthcare, Internet of Things, cloud, insurance, retail, there are always ways to compare groups and subgroups of these things, too. The BSIMM organizes things into 4 domains and 12 practices. All you need to know is the number 12, because when you look at this little chart, there are 12 little lines in the spider chart, one for each of the practices. And we can do stuff like say, here's the average of every firm on earth, all 120, and then we can compare ourselves. We look like the Starship Enterprise. You sort of see that? Like on top of the rest of the planet, and we can figure out whether we're ahead or behind. We'll call it measurement. It's kind of like, are you tall enough to ride the ride? Maybe. You can pretend. Right? So this firm is behind in security features and design and strategy and metrics, but they're doing okay on a bunch of other things. Code review, they're ahead of the curve. So if you want to know how you stand compared to the rest of the BSIMM community, you can get that vice president level chart, or you can get this geek level chart, which shows those same 12 practices, which have a whole bunch of activities underneath them. So here's the training practice, for example. And we can say, look, 80 firms out of 120 do that practice, which happens to be do some awareness training for your development people, right? But only 80 out of 120, that's kind of interesting. That means 2/3 of the firms do that sort of thing, but the other third don't. The cool thing about these data is they tell you what's actually happening out there in the world. I think that the BSIMM paradigm can be used to compare apples to apples in all subsets of security. We happen to do it for software security. I think you could do it for every single aspect of security. As long as you come up with a measurement tool, then you can do science. And if you use the same measurement tool consistently, like say you get like a column of mercury and you draw some lines on it and you put 0s and 32s and 100s and 212s on there and whatever, and you use it a lot and you use it consistently, you end up with a thermometer, which turns out to be useful for us monkeys, right? Your thermometers don't need to go so high in Norway, right? They're cheaper because they're shorter, like something like that. But we need those tools in security, and that is an example of one. So, give you some places to learn more, and then we'll have question time. This is the logo for the machine learning stuff. I wanted to show you because there's a cow on there, but the coolest part about the cow is that spot in the middle is actually my rural county in Virginia. So it's that shape right there. So yeah, retirement's mostly about cows and stuff. Here's some pointers. I have a website with like zillions of things. Most of the things are, free download. There's 13 years worth of the Silver Bullet podcast, which you may have heard of. There's a whole bunch of stuff there. There's a pointer about BIML, and there's my email address. Now, I'm not going to offer free beer during question time. I'm going to offer free shots of rum. Yeah. Yes, thank you. Who wants a free shot of rum? Come on. There's one. Oh, thank goodness. Is that the geek guy over there?
I've been following your BSIMM for many, many years. It's absolutely fantastic.
Thank you.
Have you thought about combining it to a threat assessment, understanding of, this framework says something about your maturity, and you combine that to vulnerability. Have you thought about combining to a threat understanding to do some risk measurements?
Yes. The problem with security is that externalities are extremely rare. So we do not know when software bugs cause security problems out in the world, except for the occasional one that bubbles up over the press threshold. We do not know, for example, how many bugs Microsoft found with static analysis and fixed. They're not telling. And so one of the biggest challenges we have in security is figuring out whether the stuff works requires knowing the result out there in the world. The way we did this in, say, car safety was we, in the United States, founded something called the National Transportation Safety Board, which also works on airplanes. And every time there was a car crash, they would write some stuff down about the car crash. So they began to build data about results and externalities that you could then link into the behaviors, like seat belts are good, brakes are a good idea, steering shouldn't fail arbitrarily. For God's sakes, don't let software do that. Oh, they didn't do that one yet. Yeah, never mind. But, that sort of stuff is what's required to do that tie. I don't think we have those data. So I would love to do that. That's why I say, in a sort of snarky and snide way, well, maybe all those firms are collectively on crack. Or maybe they're a bunch of adults with huge budgets. They think they're doing the right thing, and that's the best we can get. Now, as a scientist, I will admit that I would much rather make a first-order measurement. I wish there were a way to measure the property of security, but there is not. So we have to retreat to second-order measurements about process. And as a person who argued for many, many years with the SEI guys and about whether process is the thing to work on in software, I would always say, yeah, whatever, give me your code. I don't care what process you followed. Just let me look at your code 20 years ago. Now I know better, and so now I think we have to do it this way. Really good question. Gets right to the heart of the problem. Don't have a solution for that one. One free rum shot. There's one more. Maybe two. Back there.
Hey there.
Hi.
This is building on the last question, I suppose. So you mentioned externalities. I assume you mean like in the economic sense.
Exactly.
Negative economic externality if third parties have social cost that they're absorbing.
Yep.
So we don't have good data on that yet, and we're measuring second-order data. But do you think there is a market failure, and do you think that some kind of top-down stuff needs to be done around not having all liability for software failure passed on to the buyer?
Maybe.
Software is eating the world.
That's a really good question. I know you're giving a talk tomorrow. Is it tomorrow or Wednesday? It's Wednesday. There's a talk Wednesday about this economics, and you'll talk about externalities and these sorts of things. Super important work. I'm going to go to that talk. Is it going to be in English? Yay! The talks this morning were very much like most security talks. I didn't understand a word. So when it comes to this economics thing, I do think that there's a role for some sort of government involvement. But I would do it like the Federal Trade Commission does it in the United States. So instead of saying, you have to build it this way to make it secure, what you say is, you made claims about security and they were just lies. So bad, right? And that kind of leverage is something that we can use that's kind of quasi-regulatory. So you're not allowed to lie. Now, I know it's weird to think that in the United States we should say to the government, you're not allowed to lie. Because we have a liar in charge of the United States now. Yeah. our country is broken and we apologize for the inconvenience. Right? So I wish that wasn't a clap line, guys. So, if we're hoping that the United States government through the FTC will push this along, I think we're going to be holding our breaths for a while, because the question is whether the United States government will continue to exist. So, who should do it? Probably some government should think about it, but they should think about it the way that I was describing. Don't make false claims about your products. If you make false claims, we're going to go after you. You can make true claims. You can even say, we're not sure. That's fine. But, security marketing has this problem. Like, I'm not sure what military-grade encryption is. What the hell does that mean? And all crypto is not alike. And so just putting cryptography included doesn't mean shit. And so, we're guilty of those claims ourselves in our own field, so we need to try to police ourselves a little bit better than we have been. Great question, though, and I'm sure there's going to be more about economics, which, go to the talk on Wednesday. I think there's minus 24 seconds, so I am done. Thank you very much. I got a cheese slicer. Yeah.